Welcome once again to New Focused Approach to Mathematics Basic 8. This is the revised edition, and in this video we are looking at equality of vectors or equal vectors. When do we say two vectors are equal? Now we are saying here that when two vectors A and B are equal, AB and CD are equal, then they have the same magnitude and the same direction. When we say two vectors are equal, they must have the same magnitude and the same direction. Now look at vector u, which is the same as vector AB, and the component is 5, 4. That means 5 on the x-axis, 4 on the y-axis. Then let's also look at the vector CD, which is 5, 5, 4, which means 5 on the x-axis as well, 4 on the y-axis. Good. Now we are saying that these two vectors are equal because 1, their distance is the same. 2, they are moving in the same direction. That makes them equal vectors. So graphically we can represent them like this. Then algebraically too, we can also look at it in terms of their x and y component. If they are equal, then the value of x component of this vector should be the same as the value of that component on the other vector as well. And so that makes them also equal. So based on this idea, we can solve questions in relation to equality of vectors. Let's take one example and see. Let's say the vector A has been defined as 2, then y plus 2. Vector B has been defined as 2, 3. And the question says these two vectors are equal. We should find the value of y. So if they are equal, then their x component should be the same and their y component should be the same. And so we can say that with the x component 2 up here, 2 up here, they are okay. But with the y component, that means y plus 2 should be equal to 3. That is the one here. In simplifying this, by making y the subject, we can have y is equal to 3 minus 2, and so y is equals to 1. And so if these two vectors are equal, then y should be equals to 1. And that is true because if you add 1 to the 1 to the 2 here, we get the same as the 3 as we see here. Let's try another example. Given that vector m is x minus 3 and y minus s minus y, vector n is negative 2 and then 2s plus 1. The question says that m and n are equal. We should find the value of x and y. If they are equal, then we have our x minus 3, x minus y should be equal to negative 2, 2s plus 1. This is what we are saying. So for that matter, the x component x minus 3 should be equal to the x component here 2. Trying to make x the subject, we have negative 2. This is negative 3 here. When we add additive inverse, it will make this portion to be 3 as well. In this case, our x becomes positive 1. It makes sense, right? Good. Then on the y component too, the whole of this should be equal, means that I have my x minus y should be equal to 2x plus 1. Now from the component of x here, which is equals to 1, then I can put 1 in place of x. Then I have this. I can also put 1 in place of that. Then I have that. So I can write 1 minus y is equals to 2. 2 plus 1 is 3. So I can put 3 here straight away. Because 2 times 1 is 2 plus 1 is 3. So trying to make y the subject, I can let 1 here be here. And this 3 becomes negative 3 here. And the y moves to become positive y here. Therefore, I can have my y to be 1 minus 3 will give us negative 2. And so, whilst my x is 1, my y is negative 2. I'm sure you can solve more questions on this in your textbook. Thanks so much for watching.